Hi there, welcome to Latent I/O. Today's tutorial is how tokenization works and why an AI can't count the letters in Strawberry. Here is the question that broke AI for an entire year, and it sounds almost too simple to even be a problem. How many times does the letter R appear in the word strawberry? Go ahead and ask your favorite chatbot right now, because today it will answer 3, and 3 is finally correct. But rewind just 1 year, and that exact same question was a running joke across the whole internet. Every model on Earth insisted, with complete confidence, that the answer was 2. So the bug got quietly fixed, and everyone moved on, except it was never really fixed at all. The model never actually learned to see the letters in Strawberry. It simply memorized the answer to one very famous question. And to understand why that matters so much, you first have to look at what the model is really reading underneath. When you type a sentence, it does not see letters, and it does not even see whole words the way that you and I do. Instead, everything you write is chopped into little chunks called tokens, and each of those tokens is then swapped out for a plain integer, a simple ID number. So the thing the model genuinely reads is just a long list of numbers, and honestly nothing more than that. Picture each token as a sealed box with a number printed on the lid, a box that the model can shuffle around endlessly but can never once open. Now watch what happens to our word. Strawberry gets split into a few pieces, something like SDR, aw, and berry. The letter R is buried 3 separate times inside those chunks, and yet it never actually appears on its own. So when the model stares at Strawberry, it sees 3 ID numbers, not 10 individual letters. To count those letters, it would have to crack the sealed boxes back open, and it simply has no eyes for whatever is trapped inside them. Which is exactly why, when it confidently answers 3 today, it is reciting from memory, not counting. And memorizing is not the only workaround, because a modern chat app is really the bare model wrapped in extra machinery. Ask it to count letters in a word it hasn't seen 1,000 times, and that wrapper can quietly hand the job to a tool, a few lines of code that count the characters directly. But that is still the product routing around the blind spot, not the model itself learning to see, because underneath it all, the letters stay sealed inside the tokens. So where do all of these tokens actually come from in the first place? Well, they are not random, and nobody ever sat down and typed them out by hand. Instead, they are built by an algorithm called byte pair encoding, and the core idea behind it is surprisingly simple. It starts with the smallest possible pieces, just single characters, and then it scans a whole mountain of text hunting for the most common pair. Maybe the letters E and R happen to sit side by side constantly, so the algorithm fuses them together into one brand new token. Then it goes looking for the next most common pair and merges again, and it simply repeats that one little move millions upon millions of times. A common word like the eventually collapses into a single clean token, while a long and rare word shatters into a handful of leftover fragments. The whole process finally stops at a fixed vocabulary, usually somewhere between 1 and 200,000 tokens. And from that moment on, the entire list is frozen for good. The model can only ever see the world through those exact pieces. Once you can genuinely see this, a whole family of strange AI quirks suddenly starts to make perfect sense. Strawberry got patched precisely because millions of people kept asking about it, but its quieter cousins were simply never famous enough to bother fixing. Ask a model to spell a rare word backwards, or to find a perfect rhyme, or to count syllables with real precision, and it will often stumble because those individual letters are still completely hidden from view. That very same blindness is also what explains why these models so often fumble their way through long arithmetic. A number like 1,000 can easily become a single token, which means the digits trapped inside it are just as sealed away as those hidden letters were. And this same lens, even explains the real cost of actually using these models day to day. On average, a single token is worth roughly 4 characters, and that is exactly why your context window and your monthly bill are both counted in tokens rather than in words. English is also what most of these tokenizers were mainly trained on, so other languages tend to fracture into far more tokens for the very same meaning. Write one sentence in English, then write that identical idea in Amharic or in Hindi, and the second version can quietly burn 3 or 4 times as many tokens. That is the same meaning at several times the price. So here is the one mental model that I really want you to walk away with today. Tokens are the real alphabet that a language model reads, and it never truly sees your letters, only these little chunks that have already been turned into numbers. The strawberry fix, in the end, was really just a thin patch stretched over one tiny spot, while the blind spot sitting underneath it never actually went anywhere at all. But once you can picture that steady stream of tokens flowing past, all of those strange little failures finally stop being quite so strange. If you want more AI concepts taken apart like this, subscribe and turn on notifications. See you on the next tutorial.